Okay, so again, if we're in class, we're going to use graphing calculators that we have here, but at home, let's look at, let's see. So at home, I would recommend, what did I write down here? If you have an iPhone, so for iPhone, I would recommend, there's an app called Calculator. Mr. Brown likes that one, but he said that it's only free for so long, and then you have to pay like $1.99 or something to continue using it. Another one for iPhone that I found was it's Graphing Calculator. X84. And then, and again, this is for when you're remote. And it's definitely going to help with this section 8-4 in terms of checking your work. If you have an Android phone, the one I found was called Almost TI. And I'll be showing you how to use the graphing calculators that we have in the classroom, but these are going to kind of be on your own to mess around with them a little bit. And then if you're going to use your PC, whether it's a Mac or if it's a, or whether it's a, I don't know, what do I want to say? What's that? Yeah, Windows or Mac. I think this comes in both versions. This is called Desmos. So you can use that with your desktop or your laptop or whatever. All right, or your tablet. All right, well, let's, at this point, let's try to go on then with what we're doing in section 8-4. So let me come over here on the side and get you guys started with, this is some review. You don't necessarily need to write this down, but this is stuff we've already done. So the first kind of rational functions we're going to graph, the basic graph that we're going to base those on is y equals 1 over x. And we already looked at that graph back when we were doing inverse variations. So that's going to be like our parent function or our basic graph. And so I'll remind you what that one looks like. That one looks like, actually, let me do this over. That looks like, that's a little better. There's one curve here in quadrant 1, which kind of looked like that. And then the other part of the graph was over here in quadrant 3. It looked like that. So we're going to do some transformations of that basic graph. A couple points to point out about that graph is it still has the same shape, even if you change it to like, if you were to change this number there on top, if you made that like a, I don't know, a 3 or something, it's still going to have that same basic shape. That's like 3 times 1 over x. So I don't know if you remember your transformations from Algebra 2A, but that is like, that makes the y values 3 times as large, so it makes it kind of steeper. It's a vertical stretch by a factor of 3. But in terms of the basic shape of the graph, we're just going to stick with this. So I'm going to say if it's 3 over x, it's still going to have this basic shape. Okay, and that's all we're interested in is that general behavior. What other points did I have for you? When we talked about this graph before, we didn't really talk about horizontal asymptotes and vertical asymptotes. So what a horizontal asymptote is, that is like, let's see, what should I do here? That's like a horizontal line that the graph gets closer and closer and closer to, but never touches it. That's called a horizontal asymptote. So I will write that out one time, and after that I'll abbreviate it. So in this graph that we're looking at right here on the left, we have the line y equals 0. That would be our horizontal asymptote right here. And you can see over here that the graph is getting closer and closer and closer to touching that. Same thing over here. Along the negative x-axis, that graph is getting closer and closer and closer to the x-axis, but never touching it. So the horizontal asymptote is the x-axis, but its equation is y equals 0. All right. So that is the, I'll write this out. That is the horizontal asymptote. All right. So asymptote, that's A-S-Y-M-P-T-O-T-E. And the P is silent. So it's asymptote. And then the other asymptote you have is on this graph on the left here is you also have a vertical asymptote. So if you have like a vertical line, and the graph is getting closer and closer and closer to that vertical line but never touches it, that's called a vertical asymptote. So for our situation here, the vertical asymptote would actually be the y-axis. And you can see the graph is supposed to be getting closer and closer over here to touching the y-axis, but it never touches it. Same thing here. The graph is getting closer and closer to the negative y-axis, but it never touches it. So now if it's a vertical line, that would have like an x equal the equation. So that is x equals 0. That's the equation for the y-axis. That's called the vertical asymptote. One other quick note I'll make, I'll let you copy that down real quick. One other note I'll make is we looked at one of these where we looked at an inverse variation where the k value is negative. So if I had something like y equals, I don't know, we'll just do -1 over x. Again, I don't know, that's the same graph again, but it has a negative in front of the function. I'm not sure how well you remember your transformations. But if you have a negative out in front of the function, it's a reflection over the x-axis. So what that does to this graph then is it takes this branch of it right here and reflects it over the x-axis into quadrant number 4. And it takes this branch right here and reflects it over the x-axis up here into quadrant number 2. So what you would get then is you would have a graph that looks like it would now be in quadrants 2 and 4 instead of quadrants 1 and 3. So keep that in mind. But it still has the same asymptotes, okay? The asymptotes are still, the horizontal is the x-axis, and the vertical asymptote is the y-axis, so that's still the same. All right, that should get us going. So now let's look at a couple of the examples here. So maybe one more reminder. The other reminder, I'll remind you of some of your transformations. Let me draw you a couple quick sketches. Again, you don't have to write this part down. But do you remember if you had like y equals x squared? That looked like, just a quick sketch, that was a graph that looked like this, right? And do you remember that if you had like y equals x minus 2 squared. Well, what that does to that parent graph, I'm not sure if you remember or not, but if you have this number that is added to or subtracted from the x, that causes a horizontal shift. And it goes the opposite way of what you would think. So if it's a x minus 2, that's actually shifts the graph 2 units to the right. So that'd be 2 units right. I think your book called that a horizontal translation. So then your graph would look like this. You'd shift it 2 units to the right. So I'm going to take this point at 0, 0 right here, and I'm going to move it 2 units to the right. And now your graph would look something like this. And again, this is just, oh, hold on. You guys got to tell me. I'm looking at the iPad screen. I just thought, I didn't see that we forgot we lost the computer screen. Hold on. There we go. All right, so I don't know where I got cut off there, but that's supposed to say 2 units right. All right, and then the other one you could have is we did ones that were like something like y equals, oh, I don't know, x squared minus 3. Now this one's different, okay? This one, the previous one was the number was added to or subtracted from the x. Now this is the whole function here. It's this whole function, x squared, the whole function minus 3. So what that does is that actually subtracts 3 from all the y values on this graph. So which way do you think that would move the graph then? If I subtracted 3 from all the y values on this graph, where would the graph go? What's that? Still can't hear you, sorry. With that fan, I'm really deaf, and with that fan running, I can't hear it. Yeah, it goes down. So in this case, if it's a minus 3, it actually goes down 3. So that transformation right there, that would be a vertical shift or a vertical translation. So that right there, that causes that graph to go down 3 units. So then your graph would look something like, we take this point at 0, 0, and we would move it, so that point right there, and we'd move that down 3. So down 1, down 2, down 3. And now your graph would look something like this. Okay, and that's just a quick review, because we're going to apply that same idea now to our examples with these rational functions. All right, so here we go. So let's go to the next page. And I want to look at these 2 examples at the top of the page. So if you're in the book, that we're on page, what is that, 593. So I want to look at these up here. So the first one I'm going to look at is this. Well, first of all, you guys remember if it says g of x right there, that means the same thing as y, right? So it's y equals 1 over x plus 4. So how we're going to look at this again is we're going to look at this as a transformation of this graph right here. All right. So we're transforming the graph 1 over x. So let's see if we can leave that in the screen here and work this out. So which way do you think that, I'll just rewrite the function so you guys can see it. So we're dealing with y equals 1 over x plus 4. So which way do you think that's going to shift the graph, you guys? Yes, perfect. Yes, it's that number again is added to or subtracted from the x. So it's going to shift it left or right. And in this case, it always goes the opposite of what you think there. It's a plus 4, but it actually goes left 4. So this transformation is going to be left 4. Now remember, the graph that we're the graph that we are transforming is this one. I'll put it here so you guys can see it. Is 1 over x, which is just this graph, right? This curve or this branch in quadrant 1, and then this curve or this branch in quadrant 3. So what we're going to do to make it go left 4 is we're actually going to kind of, you got those two asymptotes, right? You got an asymptote right here, a horizontal one, and you got a vertical one right here. And you're actually going to kind of move those. So right now, 0, 0 is kind of where those two asymptotes cross each other. And so what you want to do is you want to move that point left 4. So what you're going to end up doing is just moving the vertical asymptote left 4 units. So you're going to get a graph that looks like this. So we're going to move it left 4. So we're taking this point right here at 0, 0. We're taking that point and moving it left 4. So we're going to go 1, 2, 3, 4. So now that point is right there. That's where the asymptotes are going to cross. So you've got that vertical asymptote now, like that. And then the horizontal asymptote stayed where it was at, right along the x-axis. And then you're going to resketch your parent function or your basic graph, this one right here. You're going to resketch it just kind of like this is going to be quadrant 1 now over here. And this is going to be quadrant 4 right here. Or sorry, quadrant 3 right there. So you're going to sketch it like in quadrant 1, it kind of looked like this, right? And then in quadrant 3, it looked like this. You can slide over a little bit. There you go. Let me fix that up a little bit. Okay, so it looks like that. All right. And then, let's see, what else should we do with this one? Let's do, I guess we'll do the second example there. So now the other example is this one. So this is example 1b here. And again, you remember that g of x, that's just the same thing as saying y, right? So this one is going to be y equal 1 over x plus 1. But then you're looking at, well, this is the function right here, right? So it's that whole function plus 1. So which way does that move the graph? What's that? Well, if it was down here, if it's added to or subtracted from the x, that moves it left or right. Well, actually, when it's the vertical translation, it goes the same way as the sign. So it's actually up 1. Okay? So again, if you were adding to or subtracting from this x, that would shift it left or right. Since it's the whole function plus 1, it's actually going to go up 1. So this transformation is up 1, or up 1 unit. I'll just put up 1. All right, so then we're just going to take our basic graph again, which is our y equals 1 over x, and we're just going to shift that up 1. Well, if we're going to shift it up 1, we're basically going to take that point where the two asymptotes crossed right here at 0, 0, and we're going to shift that up 1 unit. So at 1 now, we are going to have our horizontal asymptote. But then since we didn't shift it left or right at all, our vertical asymptote is going to stay at x equals 0 or along the y-axis, like that. And then we're just going to regraph this thing again with kind of like in quadrants 1 and 3. So there'll be one branch of it here, and then the other branch will be here. So it looks something like this. And then, we're not talking yet exactly about where, this thing crossed the x-axis, like right here, but we will get into that later on. Carter, you all right over there? You sure? Again, if you write this stuff down, again, it will be posted on Schoology, but the video of this. But again, you can use all this stuff on the test. So that's the purpose of writing it down. All right, that's all we got to do for those two, right? I think that's all it said was just to get a graph, right? Let me verify that real quick. Yeah, it said use the graph to describe the transformation. Well, describing the transformation was the up one, okay? And then graph it, so we're good. All right, let's do this example 2 here. So this one now says to identify the asymptotes, the domain range, and we don't have to graph it, I guess, but we probably will just because it'll help us. So we're going to look at this one, this example 2 right here. So again, this thing is the same as y right here, right? So that's y. And then you guys tell me, what's the, let me move this down a little bit. What's the +4 do with it right here? So we're combining, oh, I lost my screen again. I thought I reset the timer on that, but I guess I did not. You guys gotta tell me when that happens because I won't notice because I'm looking at my screen. There you go. Okay, so the +4 there, which way does that move the graph? What's that? Yeah, good. So that's up 4. So it's up 4. And what about the +2 here? Good. That's the opposite way, right? It's a +2, it's actually left 2. Okay, so we're just going to take our basic graph of our inverse variation 1 over x, and we're going to shift it left 2 up 4. So let's do the graph first, because I think it's easier to answer the questions if you do that. So we'll put the graph over here. And we're going to go, I guess I could label everything for once here. So basically, we're going to take one of those asymptotes cross, those vertical and horizontal asymptote across that 0, 0. We're going to move that point left 2 up 4. So left 2 and up 4. So now those asymptotes are going to cross right there. So then the vertical asymptote gets shifted left 2. And the horizontal asymptote gets shifted up 4. Like that. And then again, we just kind of draw this then like it's in quadrants 1 and 3 kind of. Let me fix this, hold on. I should scroll down a little bit, I need a little more room. There you go. So kind of like it was in quadrant 1, we'd have one part of the graph. Actually, I should probably extend my y-axis. That would probably look a little better too. So let me do that real quick. There you go. So we'd have part of the graph here in quadrant, like it was in quadrant 1, would kind of look like this. And then the other part would be over here like it's in quadrant 3. Kind of like that. All right. Now there's a lot of other stuff we got to do with this one though. So this one said that we also had to talk about the domain and the range, and we had to talk about the asymptotes. So we need the equations of the asymptotes. So this horizontal asymptote right here, when it's a horizontal line, that's a y equals equation, right? So we're going to put a little note here. We're going to write the horizontal asymptote. We're going to abbreviate this thing now. The horizontal asymptote is y equals 4. Okay? That's a y value of 4 right there. And then same idea with the vertical asymptote. The vertical asymptote, When it's a vertical line, that's an x equals equation, right? So we're going to write the vertical asymptote that is a vertical line at x equals -2. All right, the other thing they asked for was the domain and the range. You guys remember, what's the domain? Sean, you okay over there? All right. This is tough. We got a lot of stuff in chapters 8 and 9. It's going to be tough stuff. Like I said, I think it'll get easier when we get into 11 and 12 and 13, but right now this is going to be tough. What's the domain of a function? What's the domain all about? Do you remember? Domain and range? Nobody? The domain is all the x values on the graph. All right? The domain is the set of all the x coordinates that come from the points on the graph. So we're going to write the domain here. So the domain, I'm going to abbreviate it with a capital D. And we're going to put a set bracket like this. That means the set of all x. Let me see if I can draw that a little bit better. It's going to be the set of all x such that, that's what that vertical line means. Can you guys tell me what's the only x value that's missing on this graph? This graph is not continuous, okay? This graph follows this branch, and then it jumps over to here, and then it follows this branch, right? So what's the one x coordinate that's not on that graph? That graph is not continuous, okay? It's discontinuous. It has a gap. Well, do you guys see that there's no point on the graph where the x coordinate is -2? So there's a gap right here. You see that? This x value is getting really close to -2 from the right. This x value down here on these points is getting really close to -2, but you got to remember that's an asymptote, so it never touches an x value of -2. So we're going to say the domain is the set of all x such that x is not equal to -2. Like that. Okay, so there, let me try to say it again. There is no point on that graph with an x coordinate of -2. So the domain is all real numbers except for x equals -2. And then if you get that idea, then we got to do the range. So I'll abbreviate that with a capital R over here. Does anybody remember what the range is? If the domain is the set of all the x values on the graph, what do you think the range is? Yeah, it's the set of all the y values on the graph. So let me see if I can make that bracket a little better. So you got to put this set of all y values. So you got to make this weird set bracket. So the set of all y values such that, that's what that vertical line means. So such that y is not equal to what? What's the one y value that's missing on that graph? What's that? 4. Yeah, it's 4. And you can kind of see it right here. You know, if you thought about what we wrote down for the horizontal asymptote, it's y equals 4, right? It's this horizontal line right here at y equals 4. Well, that means there is no point on the graph that has a y coordinate of 4. So the range is all real numbers except for y equals 4. So we're going to put a 4 right here. And there you go. And I think we answered all those questions now. So we only have one more thing to do. We're about 2/3 of the way through this. So let me see if we missed anything we were supposed to do. We were supposed to identify the asymptotes. We did that. The domain and the range. And they didn't tell us to graph it, but I think it makes sense to go ahead and sketch it because you can read the information right off the graph. You can see that's what they did right here on a graphing calculator, is that same graph that I drew. Okay, let's try the last example then. So the last example, at least, again, we're going to split this over 2 days. So the last example I think is on the next page, or no, is it on this page? No, it's on the next page. So we'll go, yeah, we'll do this one this time. So this one says we have to identify the zeros and the vertical asymptotes of this function that they gave us right here. All right? And then graph it. Well, first of all, you got to know what zeros are. Excuse me. Zeros, those are the same thing as x-intercepts. So I don't know why they don't just say that, but those are x-intercepts. Those are the x values where the graph crosses the x-axis. Okay? So those are the x values where the graph hits the x-axis. And sometimes they also call those, just so you know, sometimes they also call those roots. So if you see the word root or x-intercept or zero, it all means the same thing. All right? All right, well, let's write this function down over here and see what we can do. So I'm going to actually write it down over here so you guys can see it. So what we're looking at is y equals x squared minus 2x minus 3 all over x minus 2. So, hold on, I gotta get my computer again. What I should probably do is just remember to move my mouse once in a while, and this wouldn't happen. There you go. So then let's talk about vertical asymptotes first, because we've been talking about those already, so we already know something about those. We'll do the zeros second. So vertical asymptotes. So vertical asymptote. Well, think about this a little bit. What can you not put in right there? What value can you not put in there for x? What would cause division by 0 there? In other words, what minus 2 would be 0? 2. So do you guys see that you can't put 2 in right here? If you put 2 in for x, 2 minus 2 would be 0, and that would cause division by 0. That's undefined. So basically, all you got to do to find the vertical asymptotes is just set the denominator equal to 0. So we're just going to set the denominator of that rational function equal to 0. So we're just going to set x minus 2 equal to 0, solve that, and we get x equals 2. Well, that's our vertical asymptote then. All right, it's the value that we cannot plug in right here for x that would cause division by 0. All right, well, let's talk about the zeros then, the x-intercepts. Well, I'm trying to think I don't think any of you guys had me for Algebra 1 or for Algebra 2A. But basically, if you want an x-intercept, here, let me write this down. So if we want the zeros, so we want the zeros, which is the same thing we know as the x-intercept, which really means that just y equals 0, right? Because if you're on the graph, think about it. If you're on the x-axis, the y-coordinate there is always 0, right? So basically what you got to do is just plug in y equals 0. So now don't write this part down because I'm going to show this in a different way in a second. But all you got to do is take y equals 0 and plug it in over here and solve. So don't write this down because I'm going to change this for you in a second. But basically what you're going to do is you're going to plug in y equals 0 and solve this thing. X squared minus 2x minus 3 over x minus 2. Now think about it for a second. If a fraction is equal to 0, what has to be equal to 0, the numerator or the denominator? Think of just any fraction. Would you put the 0 on the top or the 0 on the bottom if you wanted it to be 0? Yeah, good. It'd be on the top, right? Like 0 divided by anything is 0, right? We don't want to put the 0 on the bottom. If we put the 0 on the bottom, that's where it's undefined. That's where you get the vertical asymptote. So basically, if you want a fraction like this, if you want this thing to be 0, all you got to do is set the numerator equal to 0. That's all. Now, if you want to, I mean, you could go, okay, let's see, how else could you do that? Another way to do this is you could say, oh, I'll multiply this side by x minus 2, and I'll multiply this side by x minus 2, and then these will cancel out. But this side over here is 0 anyway, right? Because 0 times anything is 0, so all you're really doing is setting the numerator equal to 0. So then that gives you a good way to, now let me erase all this stuff so that we can actually deal with what we got to do. So what you're doing, if you think about this process we're doing on this problem now, is if you want to find the vertical asymptote, you set the denominator equal to 0. Well, then if you want to find the zeros or the x-intercepts, you're going to set the numerator equal to 0. So for this, we're going to set the, so I'll just write this right, set numerator. So the numerator is equal to 0. So we're just going to set x squared minus 2x minus 3 equal to 0. So basically, I'm not trying to say this over and over again, but if you want to do this part, the vertical asymptote, you set the bottom equal to 0. If you want to do this part over here and find the zeros or the x-intercepts, you set the top equal to 0. That's all you do. And then you got to solve it. Now, the only way to solve this one is you got to remember your factoring stuff. That's why when in the first week there, we were practicing all that factoring. And I said, if you can't factor these things, you can't do chapter 8. All right? So on this one, we need two numbers that multiply to negative 3, where the same two numbers add to negative 2. So what would that be? Good. So that would be negative 3 and a positive 1. So now if you multiply these together, you get negative 3, but if you add those two together, you get negative 2. All right, now I don't know how much you remember about this, but we've got to finish solving. So what we have here is the product of two factors set equal to 0. So that means either this one has to be 0, because 0 times anything would be 0, or this one could be 0, because 0 times anything would be 0, or it could be 0 times 0 equals 0. So because of this multiplication right there in the middle, what we do, here, I'll remember to move my mouse there. What we do is we set each of these factors equal to 0 real quick. So we do x minus 3 equals 0, and we do x plus 1 equals 0. We solve both of these, so we subtract 1 on both sides. We get x equals negative 1, and then we add 3 on both sides on this one, and we get x equals 3. So those are your two x-intercepts. Now somehow, based on this information, we're supposed to be able to graph this function now. Now this function here, this is not as simple as the ones we had before, right? This is not a transformation of the graph y equals 1 over x. But it's still going to have those same kind of ideas because we know it's got a vertical asymptote, right? So I'll tell you right now, if I come down here and start to sketch this, if you have a vertical asymptote, so let's say you have a vertical asymptote, it's either got to look like where it's going up on the left and down on the right, or it's got to look like it's going down on the left and up on the right. That's how the vertical asymptotes work. So it's got to be one of those two cases, all right? So let's see what we can do to start getting a graph going here. So there's my y-axis. Here's my x-axis. Let me label all this stuff for you guys. And then I know my vertical asymptote was right here at x equals 2, right? So let's put that on the graph. So I've got to have a vertical asymptote at x equals 2. So that's going to look something like this. And from over here, I know that my graph crosses the x-axis at x equals 3 and x equals -1. You guys bear with me. This is the last example. So at x equals 3, my graph crosses the x-axis, and at x equals -1. So I know that this point right here and this point right here are on my graph, okay? Now, the question is, how do we figure out whether the thing looks like this top case right here or this bottom case right here? So what you're going to do is you're going to have to plot a point. Remember when you first started graphing, they used to make you make a table? You're going to need to do at least one point. I think you can do it with just one. So let's make a little table here. So I'm going to make a table. This is x and this is y. And I think I need one x value to pick. So what I want to do is I want to pick an x value that's close to my vertical asymptote right here. All right? So I want to pick an x value close to x equals 2. Now you could pick x equals 1, maybe like right here, but I'm going to go a little closer. I think I'm going to pick 1.5. So I'm going to pick an x value of 1.5. And I need to figure out the y value that goes with that. Let me make that a little more legible. There we go. All right, so in order to get the y value that goes with it, I got to plug that 1.5 into our function, okay? So again, the x value that I picked, let me draw a little point in here. So I picked right here, I picked 1.5 for x. So let's plug that in. So my original function, I got to get that. My original function's way up there. So let me write it down again so you guys can see it. What was it again? It was y equals x squared. What was it again? Minus 2x minus 3 over. Gotcha. Thank you. So basically, we got to plug 1.5 in for all those x values. So let me do that real quick. So we're going to go y equals 1.5 squared minus 2 times 1.5 minus 3 all over 1.5 minus 2. And we can use our calculator to do that if we want. Just make sure if you put that in the calculator, make sure you put some parentheses around this entire numerator and that entire denominator. Otherwise, it'll get messed up. So if we do that, let's see if I can do this real quick. Let's see, what would that give us? Y equals 1.5 squared, that's like 15 squared is 225, so that's 2.25. Minus 2 times 1.5, that'd be minus 3. And then minus another 3. All over 1.5 minus 2, that's a negative 0.5, right? So in the numerator there, I got negative 3 minus 3 is negative 6. Negative 6 plus 2.25, that would be, what is that? That's a negative 3.75 over a negative 0.5. Negative divided by a negative is a positive. Dividing by a half is the same thing as multiplying by 2. So I get 2 times 3.75, which is 7.5. All right, so now let me go back to my little table. So my little table here is when x is 1.5, y is 7.5. Let me move my mouse again so my screen doesn't turn off. There we go. So I got to plot that point. So maybe I better extend my y-axis up a little bit higher here. So let's do that. That's not too bad. So there's my y-axis. I got to go up. I got to go 1.5 right and then 7.5 up. So I got to go 1, 2, 3, 4, 5, 6, 7, 8. So I'm at 7.5. So that point is going to be 1.5, 7.5 is like right here. Maybe not there. Hold on. Let me extend my vertical asymptote a little bit too. So like right in there somewhere, right? So that is my point 1.5, comma 7.5. All right, now, based on that, just that 1 point, you guys tell me now, does the graph look like this top case, or does it look like that bottom case? What do you think? It's either going up to the left and down to the right of the vertical asymptote, or it's going down to the left of the vertical asymptote and up to the right of it. And I gotta know, Carter, you're saying it's a top case, right? You are correct. Because picture that. It's like that point's like right here, right? That point right there, that point is acting like that point right there. So Carter is correct. It is this case. So our graph looks like, well, it's got to cross the x-axis there at -1, so it looks something like this. So it looks something like that. And then if it's going up to the left of the vertical asymptote, it has to be going down to the right of the vertical asymptote. And it passes through the point where x equals, or that it passes through that x-intercept of 3. So our graph looks something like that. Now, we don't know exactly how this part's curving right here or how it's, curving over here, but we do know that it crosses the x-axis at -1 and at 3. And that's it. That's a lot. So let's see if we did. I want to make sure we didn't miss anything that we were supposed to do on this problem. So we were supposed to identify the roots, which we did right here, or the zeros or x-intercepts. We were supposed to find the vertical asymptote, which was right here. We got that. And we were supposed to sketch a graph, which we did. So we got all of it. All right, now you can see their answer right here, which looks pretty similar to what I just did for you guys right here. Now, these are also the problems where we're going to want the graphing, like when we get done with this, then you're going to want to be able to check it on the graphing calculator real quick to make sure you did it right, and then I'll show you how to do that tomorrow. All right? The last thing I'll tell you guys for today is, well, first of all, I got to tell you what your assignment is. That's already on the board there, but I'll write it down for the people that I'm going to post it on Schoology for. So the assignment for this one is, this is page 597. You guys got 17 through 25. But that's on the board over here to my left. The other thing I want to do today, and I want to tell you to do this before I forget, is for tomorrow, let's see, what page is this in the book? So this is page 594. So for tomorrow, you're going to want to copy this box down at the bottom of page, what did I just say it was, 594? See that box right there? Here, I'll write the page number down here. Page 594. So you guys that are the guys that are home remote right now, they're also going to write that down. Normally, I would write that down. I'd give you like a 3x5 card, and I'd let you use it on the test. But we're going to use open notes on all the tests, so just write it in your notes. So take the time today to copy down that box right there, because that's one of the two things that I have to explain tomorrow, how all that works. But that is for tomorrow's lesson, and then you'll have it for the test. All right, let me stop this recording. If I can get it to stop. It does not want to stop. I don't know what happened here. Hold on. There we go. I'm back on there. How come I can't get it to stop? Maybe I've got to zoom in a little more here.